Hello folks, got a lot to talk about, so let's try to get through this as quick as possible. This will be one of my final updates on the storm tomorrow. The storm will be ongoing tomorrow, so I'll try to do another update, but there's a lot to talk about. This is basically all of the models have the same track for the storm now. There isn't too much of a difference, except there is still one minute difference between the European and the American, and we'll get into that in a second. This is the European wind map. This is your southern, or your piece of energy coming into the Pacific Northwest. That's going to move southeast. An eastern portion of this is going to combine with the northern part up here, as we said, and the European combines them right over the central part of the country here, which is the difference between the European and the American. So here we go. And see that? The eastern part of this piece of energy combines with the northern part of that piece of energy. This is kind of like a clipper system, so you have the phasing of the clipper system and the southern piece of energy here, and they phase. Now, what this does, the southern piece of energy keeps the northern part from moving further south. So this track is just a little bit farther north than the American model. The American model has the southern piece of energy staying out in front, and that in turn has the storm going just a little bit further south, but not by much. Not enough of a difference where the forecast needs to be changed. So then these two come together, right? You're taking in moisture from the Gulf. You're going to have the boundary between warm and cold air setting up. You have high pressure over here, so your boundary is right along this area here. So this is your storm, by the way. As that moves east, it's going to rapidly intensify. You're at 1,000 millibars right now. So here we go. Bam, look at that. We go from that to that. Just look at that. That's really pretty big. Now this is neutrally tilted, so it's going to move due east for a little while, but then it becomes negatively tilted, so it moves northeast, and it's absorbing moisture from the Atlantic and the Gulf at the same time. Okay? Watch your map here. So that's your storm right there. That's really, really huge. 980 millibars. Look at that. So you go from 1,000 millibars 24 hours later. From that, 24 hours later, 980. So the European takes it like this. Just north of New York City and Long Island. So your heaviest precipitation is going to be on the northwest side, and I'll explain why in a minute. I'm going to use the American model for that. So your track goes from here all the way up there, because the eastern part of the southern piece of energy keeps the northern piece of energy from digging further south. So this is a more northern track. And if just want to point out the other thing, that's way too far. Hold on. Your Arctic air is going to try to work in as the storm's going on, but it's not going to make it very far. So it's only going to make it a certain way south, and then you're going to have southerly flow coming in, meaning winds are going to be coming from the south, moving north as this storm moves up. So you're going to have warm air moving into these areas still. So that's why areas south of basically southern New York, south of I-80, you're not getting a big snowstorm. Areas north of there, you have northwesterly flow coming in. That means southeast winds. When we say northwesterly winds, that's where the winds are coming from, for those of you who don't know. So technically the winds are moving southeast, but we call it northwesterly winds. That just confuses me, but so that's that. Alright, and then your storm rapidly strengthens as lift increases. You have the boundary between warm and cold air, so that's going to increase instability. The storm's going to strengthen as it's absorbing moisture. What happens is, I'll show you on here. So we're done with the European. Let's go to the American now. And I just want to show you, number one, here's your disturbance. And look at what the winds are pointing northeast now, so this is going to kind of swing through northeast. Okay, so that's why it moves northeast. This is your jet stream right here, moving up and down like that. So it's on top of the jet stream, it's going to move up like that. Okay, over New York City and Long Island pretty much. Now, here's what's going to happen. Excuse me, my voice cracked. Alright, so here you are on Thursday evening. Now, here's your storm. You have southerly flow bringing in warm air, and you have northerly flow bringing in cold air on the backside. So anywhere on the northern or western side of the storm, you're going to be cold enough for snow. Now here's what happens as this moves up. The other one's kind of better. But you're going to have these winds here that are circulating around the low. The low is going to usher in that warm air into the colder air, right? So all this warm moisture is going to be coming into the cold air mass. And warm air is not as dense as cold air. So what happens is the warm air and the warm moisture, they all rise above the cold air. And it condenses. And then it goes through the cold boundary layer and you get heavy snow. And this storm is going to be really strong. It's going to be 980 millibars by the time it's up here. So the winds around it are going to be really strong. So it's going to be taking in a lot of moisture, a lot of water, a lot of liquid. That's going to form very heavy snow. And notice that when you get in here, the winds start to point that way. So that's why on the northwestern side of the storm, that's where you're going to get your heavy snow, northwestern. So as this moves up, your northwestern side is going to get the heaviest snow. Okay, so this is the American model, by the way. These areas up here, you're going to be all snow the entire time. Areas south, you're going to be mainly rain. Alright, now let's look at what the newest run of the American model has in store. Here we go. Alright, so this is the newest run. Check this out. You have your northern piece of energy, your Clipper system. Your southern piece of energy is this whole thing. You have the eastern portion of it right here. And what it does is it keeps this part out ahead of the northern piece for a little longer than the European does. So watch this. Still out in front. Still out in front. Still out in front. And now they're combined. Took a long time, right? And because of that, and again, it's not a big difference. It's not really a big difference, but because of that, your negative tilt isn't going to happen until there. So your storm track is going to be just a little bit farther south. Alright, so here you go. Your Arctic air mass is up here. Your storm is down here. Alright, here we go. Look where it goes. We are now Wednesday night. And there it goes. See, it's just a little further south. The European brings it just a little further north. Not too much. This is not a big enough difference for us to change the forecast, but that's your difference. And now we're going to look at our precipitation map. Alright. So this is from earlier tonight. This is still tonight. Or, excuse me, that's early Wednesday morning. Alright, early Wednesday afternoon. Check it out. Your heaviest precipitation, again, is on the northern and western side of the storm. Because southwesterly flow, northwest wind, is going to be bringing in that moisture. Then it's going to come in rapidly. It's going to condense and form heavy snow on the northwestern side. Alright, so that's why your precipitation map is heavier on the northern side of the storm. Now, here we go. Alright, this is Wednesday evening, early Thursday morning, 1 p.m. Thursday afternoon, 7 p.m. Thursday evening, and then it's all gone. So it's gone by Thursday. Alright, that's your precipitation map. So there you go. That's what the models are showing. So I'm going to set up a map now. Oh, and quickly. You're going to have a little bit of wind shear. Excuse me, hold on. If I can find it here. Why am I not finding it? Effective bulk shear. Okay, so here we go. Alright, so notice as we get into Wednesday, you have pieces of shear moving up the coast. That's because you have a cold air mass and a warm air mass. Winds are going to be going in different directions. That creates shear. It also creates lift in the atmosphere. So you're going to have to watch out for thunderstorms in this area, and some of those could be locally strong. I don't think we're going to get severe weather. Maybe 1 or 2 severe thunderstorms, but I don't think it's going to be that big of a deal. You might see some instability developing down here because you've had such warm temperatures. So you will probably have Cape values of in excess of 500 to 1,000, which, again, for severe thunderstorms, you typically need 1,000 or higher. So you're going to be around 500 to 1,000 down here. So I think you might be able to see some brief severe storms in this area. I would say the main threat, you have shear, probably damaging winds, maybe some hail. I don't really think hail is going to be that big of a threat. Let's see here. Do they have lapse rates? That's what I would need to look at. Here we go. Yeah, you're not going to really have much of a lapse rate. Okay, that would be lapse rate is a measure of how high the cloud travels in the atmosphere. So if you take a look here, we're looking at this area here. So this is the probability that lapse rates are higher than, I think, 7 or 8. So again, look, the probability stays very low. So I think your main threat is going to be heavy rain, damaging winds, if that. I think you're going to definitely see some gusty winds, 40, 50 miles per hour with a couple thunderstorms. So the area that would be in the threat there would be from central New Jersey, southern New Jersey, southeastern Pennsylvania, extending westward into eastern West Virginia, most of Virginia, Maryland, Delaware, maybe into northern North Carolina, not sure about that. But that would be your main threat for locally strong storms and possibly severe. In this area here, southern New England, you might get some normal thunderstorms, but the dynamics, like you will have some shear, but it's not going to make it that far north. So you're mainly going to be rain, but you could see a couple of thunderstorms, couple rumbles of thunder. So that'll be tomorrow afternoon, because temperatures are going to be in the 50s around here. All right. I don't think there's anything else I wanted to talk about, except I did want to show you. Oh, here we go. I wanted to show you temperatures. Okay, so let's go to 15 minus 5, 10 a.m. Wednesday. Look, you already have your 40s up here. Your 40s up here. So you're going to be cold enough for snow from this line north. So you're going to be all snow from Albany northward. So that's where your heaviest snow accumulation is going to be. Sorry, I'm fixing my position on my seat here. I apologize for the shakiness. I will be getting a new computer soon, and I will use a screen recorder to take these videos. But anyway, you have Arctic air trying to work in. See, it's on the back side. That's why this area is not getting a snowstorm. Okay, now let's go to Wednesday evening. Again, you're still cold enough for snow, but only north of this line. You're still going to be rain this area south. Oh, I'm sorry. North of this line, you'll be cold enough for snow, but still south, rain and snow mix, and then all rain in the green area, because that's going to be 40s and 50s. Okay? And then if you go to 4 a.m. Thursday, look at that. Everybody's cold enough for snow. That Arctic air is working in behind. Your storm is up here now. Arctic air is working in behind it. And that is that. Alright, so that's your temperature forecast there. So it's going to cool down really quick on Thursday, because you have the high pressure up here, and then you have northerly flow bringing in the cold air right behind the storm, rather than on top of it, which is why not everybody is getting a snowstorm. Alright, next video we'll talk impacts.